Okay, what I'm going to go over is an explanation of what is topography, which is referring to the site work, and in a little bit more detail, what are contours, what are contour lines in relationship to construction. Okay. Oftentimes, or if you ever find yourself in a situation where you are working on a hillside, then you really need to understand the topography and what are contour lines and how this all kind of plays into building. So down here, I pulled up two images just so that we have a reference of what it is that we're talking about. Really quickly, when I say the word topography, what I'm referring to is the site, is the landscape, or it's the land itself. So I would say it has a hilly kind of topography, right? The topography is a hill. Down here, we have what I think is maybe the most recognizable uh, topographic map, which shows the contours. Okay. The contours are all of the little lines that you see. Now you'll begin to see numbers. Okay. And these numbers lets you know the height of this line that is associated to that number. Okay. And this number represents a unit. If it's an imperial map, so an American map, these are going to represent feet. So this represents 1,450 feet above sea level. Okay, 1,350 feet above sea level. Okay. And these are the lines we call contours. Now over here on the right is more of a um, topographic map that we use within construction. This image here is actually an image of the infamous Mulholland Drive. It's just a really small snippet of Mulholland Drive. And I got this image off of the city of LA's ZMOS, Z-I. You guys can all check it out if you want to. ZMOS. Oh, I believe it's .org. Which is where you can get all sorts of information for any property that is within the city of Los Angeles. And then there's a way there that you could actually pull up the contour map and the individual track map. So these are the individual properties. Okay. But what you'll also notice here is that we have numbers. Okay. Now what you'll notice is that if we zoom in, we have darker lines and we have thinner lines. Now, darker lines typically represent, or not typically, they represent what we call our major contours. And then the lines in between represent minor contours. Okay. Now, typically they are broken up into segments of 5. So you'll typically have 4 minor contour lines, and then the fifth one is going to be a major contour line, and then 4 minor, and then a major, right? So it's the same thing over here. If we could count, we have 1, 2, 3, 4, and then a major, right? And same thing over here. Now, what we end up doing is we take 2 major contours, okay, and then we'll see how this gets broken up into 5. So there's 25 feet from here to here, which then means that each one of these lines represents 5 feet. So that's 1,200, 1,205, 1,210, 1,215, 1,220, and then 1,225. Okay, so that begins to tell us what the distance is between each line. Okay, but let's kind of break this down. What do all of these lines actually represent? And ideally, what you want to be able to begin to do is to look at a topographic map and visualize 3-dimensionally what this site actually looks like. Okay, so with a little bit of kind of practice, you can begin to maybe 3-dimensionalize the topography in your head. So what I have up here is just a little kind of makeshift section of a hillside. Okay. Now we have the hill. I made a little house at the top, and then it kind of dips down, and before dipping up, and then it slopes down radically. So the first thing we would do is think of contours as cuts through the hill. Okay, broken up at, let's say, every 5 feet. So we would break this up and we would cut the land in 5-foot increments. Okay. And I would say, you know what this is? I don't know. Let's say we are 400 feet. This would be 405 feet. This is 410. And this would be 415. And let's say this is 420 feet. These are our major lines. Within these major lines, we're going to have 1-foot increments. Okay. Now, when we're dealing with construction, when we're dealing with the site itself, we typically want 1-foot increments. Okay. And the reason why we want 1-foot increments is because that gives us the most detail. Now you have to imagine that we're building a house, so therefore we need to know exactly where and how the topography moves. If we just showed 5-foot increments, a lot can happen within 5 feet. Okay? So we would have these, we would think of this as slicing the land every 1 foot. Okay, right there, right there, right there, and so on. So what we then would do is look at this. Oh, that's a bad arrow. From the top down. Okay, now from the top down, I might see, let's start with the 400, with the 400 foot. Now this is just a slice through, so let me just pretend, oh, let's not do that. Let's just pretend that this is my 400-foot line. Okay. So then I would draw the 405-foot line. Now that's going to look closer, probably going to be around here. And let's go ahead and go 405 feet. We'll go 410 feet. Now watch what happens with my 410 foot. I have a marker there, there, and there. So that means it's going to be somewhere like that. And then it's going to be somewhere. So I'm drawing this point, and this point is probably right there and right there. And then I have a smaller section right there. Okay, so this is, again, as if I'm drawing this from the top down. Then my 415 is going to be there. Okay. Now I want you to notice, obviously I'm eyeballing this, and then 420, I'll just say it's something like that. I want you to notice one thing, which is look at the spacing from there to there versus the spacing from there to there. Or let's take a look at that, these two, right? I drew this closer and I drew this line farther away. Because if you think about it, which one are we looking at? We're 410. If we look at 410, okay, the distance from here to there is a lot closer here, sorry, let's do 415. The distance from 415 to 410 is a lot closer on this side than it is on this side. Okay. And the point that I'm trying to drive across is that the closer the lines are to one another, okay, so the closer they are to one another, that means the steeper the topography is. When the lines are farther apart, then that means the flatter the line is. So when I look at, let's say, some like this map here, let me go ahead and erase these lines. This tells me that this major line here, which is, let me look for this. Do we have it? We don't show it. Yeah, this is, let's say, I don't know. Oh, so here's 1100. So that means that this would be 1125. Right, follow that along. If this is 1100 and this is 1200, that means the hillside is going up. And if these are 25-foot increments, that means that this is 1125. This line is 1150. There's this line here that's getting kind of blocked by this black line. That's going to be 1175. So zooming in over here, what this tells me is that the land is, and if let's say I'm trying to look at this property right inside here, this tells me that the land is a lot steeper and it's coming up, okay? And then it flattens out, and then it kind of flattens out even more like this, right? So that tells me, based on these numbers, okay, that the hill is coming up and then it gets flat and then it gets flatter. Okay. And so that means that if I was just by looking at this topographic map, that's going to tell me that, well, there's a good chance maybe what I want to do is build the house right over here, and that the view is looking out that way. And that I have a hillside and it's a pretty steep hillside and it's a pretty steep dip. So I probably can't build here, or I'd have to kind of excavate, flatten it out, right? But that's kind of the information that I get over here. And that's simply by reading the distance and seeing the spacing between these lines and noticing how they get farther and farther apart. Okay. Now we're going to go into Revit and we're going to begin to build our own topography. And we're going to do that by telling Revit, we're going to give Revit heights. And we're going to say, give me a point there at, let's say, 5 feet. And then give me another point here at, say, 7 feet. And then another point there at 10 feet. So we are going to build our own topography, okay, inside Revit, so that when we add our house, we can go ahead and excavate if we need to like cut some land out, okay? Or we can model out on flat land, but show the hillside behind and show kind of a dip at the front of the house. Okay? Ideally, you always want to build a house on flat land, which means that we then would have to kind of cut and excavate part of the landscape or part of the topography to flatten that land. Okay. But before we do all that in Revit, I wanted to make sure that we all had an understanding of what is topography, what are contour lines, and how they all kind of relate to the construction industry. Okay, hope this helps.